Did you lose power over the ice storm break?
Yeah, the campus lost power.
Wow, for how long?
It was from, I want to say Monday or Tuesday till Thursday.
Tuesday, Thursday, okay.
I think it's Tuesday to Thursday.
Okay. Well, they didn't have a scheduled break, but Mother Nature decided to give it for us, and I'm kind of happy about that.
It was nice.
Well, guess what? Now we don't have to do a whole chapter. Chapter 7, forget about it. We don't have enough time. So there is no chapter 7 anymore. The whole class will be over the final will be over chapters 1 through 6. We're going to stop at 6. And we only have time, if we go through a section per class, we only have time to end chapter 6. So before the last class periods are finished. So also that whole, you'll be able to like have optional classes. That's disintegrated because the ice storm break. So yeah. We got the break before sooner than expected, but yeah, that's what happened. So, all right. So, what we're going to be talking about is 5.4, and part of the semester, the homeworks have been graded. All right. And from some point on, I haven't determined when, but from some point on, I'm going to make the homework and quizzes completion. So if you showed up and you tried your best, I'll give you your full points. That's the least I could do for making the tests very hard, right? If they're extremely, extremely hard, I'll give an even added curve as usual. You guys know how I am. Really tough, and then at the end I show some mercy. So yeah, I'm probably going to make some of those assignments just completion. If I see you turn it in, I'm just going to give you points because yeah, during the break, although my home didn't lose power, my wife's family and my family, they all lost power. So we had like in a 2-bedroom, 1-bathroom home, we had about 11 to 12 people. So it was crazy. I couldn't be productive at all. Yeah. And of course, half the time we're hauling tree branches, right? So.
Do we have another test and then final or just the final?
That's a great question. I don't know if I should do that or not. What I might end up doing is just have a final. But if you would prefer to have another test to kind of help bolster, I don't know, some type of grade that you're looking for, I can do that. We had a test over chapters 1 and 2, 3 and 4, and then we can have a test over just 5 and 6, and then a comprehensive final. If you guys want, we could do that. If not, I may still end up doing that because the syllabus says 3 tests and a final, but I don't know. It's my class and I can run it how I want. I may or may not do it based off of I don't know, based off of just like timing. Because if we're even to get through all of chapter 6, if we go through a section a day, then we don't have time to do that. If I go through multiple sections a day, we can. But I don't know if that's setting you guys up. I don't know if that's setting you guys up to do well or not, because this is not the only class you guys are in, right? How many other classes are you guys in?
4.
You're in 4 other classes. How many about you? 4 other classes, yeah. So It's not your only class. If I just ramp up the rate at which you're being fed material out of nowhere, it might compromise your standing in other classes, and I'm not comfortable with doing that. I'm not comfortable doing that because I once was a student just like you. I actually went to SNU as well. I wouldn't like that done to me. So no problem. Yeah, I got you guys' backs, man. As you guys can tell, my only hidden agenda, which is not so hidden, is that I want to convert you guys to math majors. You should do it. It's really cool. You can stay your major, but if you ever get tired of memorizing all day, come on over to mathematics, where you just got to think your way and, wiggle your way to the answer. There's not that much memorizing. All right. So let's talk about 5.4. And in terms of quizzes, I don't know if I'll do any more quizzes. I might do them just to like show you concepts I find important. Then won't be for a grade anymore. Homework will be for your information. And if you guys have any questions about the homework, let me know. Might do that at the beginning of the class. Also, there was that promise I made you guys to read your quizzes on the first day of class. Totally forgot about that. Like there's a bunch of them that I haven't done yet. So I'll try and make sure to get those also out of the way so nobody feels left out. Yeah.
And that extra credit is still valid. Right?
Yes, still valid. If we don't have a third test, I'll apply it to the final. If we don't, if we probably, yeah, I don't know. Again, to have the third exam, we'd have to like shove more material. I don't know. We'll see. We might do it, might not. But let's live life day to day, and let's try and get through some information here. Let's talk about product to sum identities. All right. Product means multiply. Sum means add. So somehow we're going to take a trigonometric function times another trigonometric function and get trigonometric functions added to each other somehow. So let's consider what was the cosine of alpha minus beta. If we remember, after we derived it, it was a cosine of alpha, cosine of beta, plus sine alpha, sine beta, I think. Let me see if my memory, is it right? Yep, it's a plus. Next, we were able to derive cosine of alpha plus beta by replacing every beta with a negative beta. So then we would get cosine of alpha, cosine of beta, and then sine is an odd function, so this is minus sine alpha, sine beta. So why are we reviewing these? Well, because we're going to utilize these two to come up with a product to sum identity. Let's notice what happens if we subtract one of these from each other, okay? Or add one of these to each other. What happens when I add the top to the bottom? Notice that sine alpha sine beta is over here, sine alpha sine beta is over here, so they cancel. So all we would get is cosine of alpha cosine of beta, cosine of alpha cosine of beta. So that's 2 cosine of alpha cosine of beta. But that's equal to cosine of alpha minus beta plus cosine of alpha plus beta. Oh, here's the product to sum formula, almost. If I divide both sides by 2, I'll get it. Divide by 2, divide by 2, bring the calculation up here so I don't have to bend my knees. Cosine of alpha, cosine of beta is a product of two trigonometric functions evaluated at different angles is equal to 1/2 times this whole thing. Cosine of alpha minus beta plus cosine of alpha plus beta. Aha, we derived it. Here's a product to some identity. We take a product and we can represent it as a sum. Product, there's a dot here, and sum, there's a plus here. And so you could get several of these by doing similar calculations. Very similar calculations. So here's one of them. You know, what I may end up doing is assign your third test to be your highest test grade, the same value. And then your final is your final. Or else your final would have to be worth like, you know, like 50%. You know, I don't know, some really high amount. So I might just say, okay, your highest midterm, that's what your third test will read, and then your final will be just what you get on the comprehensive exam. Maybe we'll do something like that. Maybe. So what about sine of alpha, sine of beta? Well, this is going to equal 1/2 times cosine alpha minus beta minus cosine of alpha plus beta. How do we get this? Oh, it's just the same thing. We can derive it. So what we did was we analyzed what cosine of alpha minus beta was and cosine of alpha plus beta. And instead of adding, we might have subtracted. So take a look. Cosine of alpha minus beta, if we recall, equaled cosine alpha cosine beta plus sine alpha sine beta. All right. And then cosine of alpha plus beta was when we just like this with a minus sign over here. Cosine alpha cosine of beta minus sine alpha sine beta. But instead, before we added them, what if we subtract? Notice if we subtract, so this thing minus this thing, when I distribute the minus, there'll be a minus here and a plus here, and making this a plus. So then, look what cancels is the cosine of alpha cosine of beta part. So now we get a 2 sine alpha sine beta. That's equal to cosine of alpha minus beta plus cosine of alpha plus beta. So if I divide both sides by 2, then I get sine of alpha sine beta is equal to 1/2 cosine of alpha minus beta minus cosine of alpha plus beta. So that's how you get that one. It's the same concept. Okay. So I won't derive the rest because they're all kind of like this. There's another one here. There's a few more. Actually, I might just put them right here level. This. We had cosine alpha, cosine beta, sine alpha, sine beta. What about sine alpha, cosine beta? Oh, I think I just reproduced it. I mean, I had cosine alpha, cosine beta, sine alpha, sine beta, sine alpha, cosine beta. No, yeah, that's novel. That's equal to 1/2 cosine alpha minus beta plus. Close the bracket. I believe that's correct. Cosine of sine alpha, cosine beta is 1/2 sine alpha. Oh, sine alpha, cosine beta. Oh, so I must have rewritten this. This is cosine of alpha, cosine of beta. I just reproduced that one. Sine alpha, sine beta. Oh, I unfortunately just reproduced that one. Sine of alpha, cosine of beta should be 1/2 sine of alpha plus beta. So these should be plus, minus, but these should read sine, not cosine. That's why. And you guys realize how to derive them, because we've derived them so far. So we got cosine alpha, cosine beta, sine alpha, sine beta. Then we got sine alpha, cosine beta. Last but not least, cosine alpha, sine beta. And when you guys take your final, you guys could just create a formula sheet. I'll give you like a sheet where you can write formulas on it. And so you don't have to memorize any of this stuff. Just learn how to use it. Cosine alpha sine beta is 1/2 sine of alpha plus beta minus okay. So here's your product to sum identities. Do not memorize them. You will be able to bring a formula sheet. Don't memorize them, just know how to use them. So how can you use them? Let's see. What if I ask you to write this product in terms of a sum of two cosines? Let's say 2 cosine of 27t multiplied times cosine of 15t. Write this as a sum of two cosine functions. So what we can do is say, hey, this is one that has two cosines in it, but with different alpha and beta. So why don't we, I'm gonna reach into my bag of chalk. Why don't we call this an alpha and call this a beta? Then we can just use that formula, right? No. That formula does not have a 2 in front of it, does it? Yeah. Out in front, there's no 2 out here, right? There's no 2 here. So how are we going to use that formula if there's no 2 here?
Divide everything by 2.
Divide everything by 2, but whenever you do something to one side, you got to do it to the other. So what is the other side? You're close.
It's would be 1/2 cosine alpha minus beta plus cosine alpha plus beta. So that's the formula we're using. Would that be
You're very close, but what you're assuming is that you don't have to divide by 2, but you do. So here's a trick. I'll show you a technique. Say, well, I know what cosine of alpha times cosine of beta is. It's this stuff, but I don't know what 2 cosine alpha cosine of beta is.
So just modify the formula?
Huh?
Would you just have to modify the formula to fit the 2 in front of the cosine?
Yeah, there's multiple ways of doing this. You could either say if this 2 is here, that means I've multiplied this equation by 2. That means there's a 2 here, and then this 1/2 goes away, and then just write that out. That's one way to do it. Another way to do it is to say, let's just set this equal to x. Divide both sides by 2. Then I'll get cosine of 27t, cosine of 15t is equal to x over 2. And then you know how to like represent this cosine of alpha and beta. And then once you're done, just solve for x, because x would be what you're originally looking for. 2 ways of doing the same thing. 2 ways of just doing exactly the same thing. Just putting a 2 here and dropping the 1/2 is also accurate. But that's kind of hand wavy, and this is more like methodical. If someone is asking you to show your work, this would be a lot better evidence of your work. Even though you could say by this identity, 2 cosine alpha cosine beta would just be cosine alpha minus beta plus cosine alpha plus beta. So notice that this would then in turn equal cosine of your alpha minus beta. Oh, actually, if it's this alone, it's going to have the 1/2 in front of it. If it's this alone, it's going to have your 1/2. This is going to be your cosine of your alpha, which is 27t, minus a beta, which is a 15t, plus your cosine of alpha, which is a 27t, and then we're going to add it to this 15t. Right? You guys see what I'm saying?
Sort of, but I thought you said that the 1/2 would go away if we're dividing by 2, or I would just solving everything and then divided by 2.
Yeah, notice that if I now multiply both sides of this equation by 2, the 1/2 goes away, and then this 2 goes away, so you just get x is equal to this stuff. It's the same thing. Does that make sense? Because if I multiply both sides by 2, this 1/2 goes away, and now this is no longer x divided by 2, it's just x. So it was the same thing as I said earlier. Just make sure you know what you're doing. Doing this whole set equal to x thing will allow you to not only show your work, but retrace your steps if you possibly made an error. So then this breaks down to cosine of what is 27 minus 15? That's maybe 12, is that right? Good, okay, and then cosine of what's 27 plus 15?
42.
All right. The question asks us, this by the way, this is x. And x is what we were looking for. And the question was, represent this expression as a sum of cosines. And we just did. So that would be like a kind of question that would apply these identities that we have on the board.
And this is for the sum, you said, the sum of the cosine, right?
Well, first we had a product and then we converted it to a sum.
Okay.
Mhm. Good question. Watch out. All right. Now we can also work the other way, if you will. We had a product to sum, but now we can have a sum to product. So what about, recall that cosine of alpha, cosine of beta was equal to sine of alpha plus sine of alpha minus beta. All right. So recall that that's the case. What we can do is do a substitution for alpha and beta. So let alpha equal u plus v over 2, and let beta equal u minus v over 2. Why are you doing that? Well, we'll see. Notice that when we do that, alpha plus beta is u plus v over 2 plus u minus v over 2. This is u plus v plus u minus v, everything over the common denominator too. The v's cancel. So now I get a 2u over 2. 2's cancel and I just get a u. Oh, that's why I did that, because now alpha plus beta can equal u. Oh, but what about alpha minus beta? Well, then alpha minus beta would then equal u plus v over 2 minus the quantity u minus v over 2. Distributing that negative and combining it under a common denominator, I get u plus v minus u plus a v, right? And now notice the u's cancel. Now I get a 2v over 2. Cancel out the 2's and I just get a v. So notice that, oh, that's why we did that. Alpha minus beta is now just equal to v. So what was the point of all that? Well, it's because now we can have a product turn to a sum. Notice that cosine of alpha then transforms to cosine of u plus v over 2, and cosine of beta turns into cosine of u minus v over 2. All right, that equals 1/2 sine of this, which is just u, 1/2 times the quantity, sine of u, and then plus sine of v. So there we go. Now we have a product with sums in it equaling a sum. Oh, and what can you do? You can also multiply both sides by 2. Let's see here. What if you want to know what sine of u plus sine of v is? You just multiply both sides by 2. Multiply both sides by 2 of this equation. And then that 1/2 goes away, so I just get sine of u plus sine of v is equal to 2 times that. So now we have a sum to product, or before we had a product to sum. It might seem silly to do this. Why are you doing this? This was a silly thing to do. Alpha equaling u plus v over 2 and beta equaling u minus v over 2. Why are we making things more complicated? Well, that's because sometimes in mathematics, in order to attain something more simple, we have to make it more complicated to do so. How can I explain that? I don't know, like knitting something. Who here's seen their grandma or mom or whoever knitting stuff? Well, the final product seems structured, right? But that ball of yarn is really crazy and chaotic. So you take that chaotic thing and you create something structured. But you can also take that structured thing and do some chaotic stuff and change the pattern. So I don't know if this is hitting home or not, but you get the point. So we now want to know what a sine of u plus sine of v is equal to. There are more identities. I'll give you them. Sine of u plus sine of v is equal to that. What is sine of u minus sine of v? It's 2. Uh-oh, let's just say sine. U minus v. How do we get that? Well, pick the product to sum that had a sine minus a sine. And then do this same step while letting alpha equal u plus v. And beta equal u minus v. Okay. What other ones are there? Let's note them. So I got sine of u minus sine of v, sine of u plus sine of v. What about the cosines? Cosine of u plus cosine of v. Cosine of u minus cosine of v. These guys equal. Cosine of u plus cosine of v. That's 2 cosine of u plus v. Cosine u minus v. And then cosine of u minus cosine of v is negative 2 sine plus v over 2 cosine of u minus v over 2. There you have it. The derivations are all very similar. So let's apply it. Let's say we're given y1 is equal to sine of 12 pi t. And let's say y2 is equal to sine of 10 pi t. Express y1 plus y2 as a product of trig functions. Why is that a big deal? Well, because just replacing y1 plus y2 is the sum of trig functions. So we want to represent it as a product. So we look to the sine of u plus sine of v and say u is equal to 12 pi t and v is equal to 10 pi t, and just replace the u's and the v's in the formula right here. What is my u? 12 pi t. Plus, what is my v? 10 pi t. Everything divided by 2 times our cosine. What is my u? 12 pi t. Minus what is my v? 10 pi t. Everything divided by 2. When we simplify, I get 2 cosine of 12 plus 10 is 22 pi t. And then 22 divided by 2 is just 11. So it becomes 11 pi t over here. What does it become over here? 12 minus 10 is 2. 2 divided by 2 is 1. So we just get a pi t over here. And there you have it, final answer. So it's as easy as that. And I want you guys to just be able to like write this on a sheet, bring it to the exam, and apply it. It might not be this simple. Maybe I might want to make it harder. Just to test you guys. It is called a test for a reason. Who knows? That might just be this simple. You never know with me. You never know with me, man. Let's do one last example before we're done with this section. And for those of you who weren't here when I was discussing this, what we're gonna have to do is we're gonna have to like not go through chapter 7. Because in order to do that, we have to go through 2 sections of class. And that would increase the rate at which you have to learn this stuff all at the end of the semester, and that's not fair to you. Because you have other classes you guys need to study for. But I don't want to make the final worth like 50% of your grade either, because that's like, you know, a lot of pressure. Even though some courses have that kind of policy anyways. But what I would like to do is maybe have your highest midterm exam for your 3rd exam. So your highest midterm exam score just be your 3rd midterm test score. And then have your final just be graded. That might be what I can do because there's no other way around it. We don't have a class period to spare if you want to get through all of chapter 6. So that's how I might do it. I'm still thinking about it. Let's use an identity to show that R of theta is equal to one over 16 v squared sine of theta cosine of theta. Let's show that this thing is equal to 1/3. I say 1/3. I think I'm at 1/32 v squared sine of 2 theta. So prove this. Prove this. I'm telling you guys, it takes a lot of skill to keep using chalk that tiny. Make sure your nails are clipped, or else you're gonna scratch the chalkboard. All right. Well, there's several ways we can do it. One way is quite easy, and I'm gonna have to say, let's start from the right. And guess what? We don't even need these guys. I already know this is gonna work. We don't even need these guys to reference them. What we're gonna use is the double angle formula for sine of 2 theta. Recall, sine of 2 theta equaled 2 sine of theta cosine of theta. Remember that? This was an identity that we've already discovered. We're going to use that. Just take that right-hand side, 1/32 squared sine of 2 theta, and replace sine of 2 theta with 2 sine of theta cosine of theta. Ooh. All right, look what happens. 2/32 is the same thing as 1 over what? That's right, 16. Oh, and we're done. And we're done. You use that one trig substitution and simplification. So I've used these so often that I knew to do that. And as per usual, I do not allow technology in class. So please do not utilize that. If you must use it for emergency purposes, you may politely, discreetly get up and use it outside. And we're almost done. Let's see what else I got to talk about. Once we discovered that, let's ask the question, if the projectile is thrown with an initial velocity, let's say VI is equal to 96 feet per second. What do we want to know? What do we want? How far will it travel if theta is equal to 15 degrees? So this equation R of theta, it represents projectile motion. I forgot to tell you that. This R of theta represents projectile motion. So we've discovered that our R of theta is equal to this other R of theta. And then we can talk about if our initial velocity V is 96, how far will it go when theta is equal to 15? So before, right here, if we stuck 15 here and 15 here, we don't know what the sine of 15 and the cosine of 15 is. Sure, we could discover it if we use our knowledge of the difference of angles, but you know, that's a lot of work. It's a lot of computation. Why not just use the fact that we've equivalently, we can express it like so, and if theta is 15, 2 times 15 is 30, we know what the sine of 30 is. So why don't we just plug in a 96 here, a 15 here, and see what happens. Squared sine of 2 times 15 degrees. This becomes 30. And sine of 30 is what? That's right, 1/2. So it's really 1/2 times all of that. So I just double that 32 and make it a 64. And I don't know what 96 squared is. So our final answer is going to be 1/64 times 96 squared. And that ends up equaling it's not even approximately, it's a full-blown equals 144 feet. That's how far it goes. The projectile will go 144 feet. Let's do one last question. From that result, determine the angle theta that will give the maximum range for the projectile. So at what angle do we need to send the projectile for it to attain its maximum distance? What do you guys think it is? Huh?
45 degrees.
Wow. How did you just intuitively know that?
I did it sophomore year. We did a lab.
Oh, you did a lab? Okay. You play football, right? So when you punt it, you know, if you punt it really high, it goes high but not very forward. And you know, if you punt it really shallow, it goes forward really fast, but it's going to hit the ground quick too. So truly, if you want it to reach the farthest it can possibly go, you truly wanted to hit it at the 45-degree angle. That way it continues to rise as it moves forwards at the most optimal value. But it's hard unless you're a soccer player like me to know how to put that 45 degree on. I'm a soccer player. I mostly played soccer. I played a little bit of football. So. I don't know why they call football football. Soccer should be called football.
There's cool people in
I
pretty much
know.
everywhere else in the world.
I know. Football should be called, tackle ball or something like that, or ellipsoid ball. But balls imply it's a sphere, but the football is in the shape of an ellipsoid. So I don't know, man. We got to kind of go to the drawing board with that one. Us mathematicians are not happy with the naming of that. All right. So you guys already know it's 45 degrees, but let's have the mathematics show that. How could we use the mathematics to show that? So remember, sine is what is in charge of the output of this function, right? Because given some velocity, and that 1/32 is constant, really what determines this function is a function of theta, meaning everything else is constant and theta is a variable. Okay, you would think that, okay, it's the highest when theta is equal to, pi/2, because that's when sine is 1 and that's when you get the highest value. But notice that there's that 2 multiplied times it. So theta needs to be something such that when 2 multiplies times it, it equals pi/2, right? So 2 times your theta equals pi/2. What is your theta? As we've discovered, as we've already intuitively said, that's when we divide both sides by 2, that's pi/4. And that's that. Why did I even set this up right here? Well, it's because this is the sine of 2 theta. And the sine of pi/2 gives us the highest value of output, 1. Every other angle gives something less than that, unless it's a multiple of pi/2, right? So as we've discovered before, the range of sine is -1 to 1, including. So the highest value sine it can assume on the unit circle is +1. So we say then, well, let's set that 2 theta equal to the highest value can assume and solve for what theta needs to be. We realize it's 45 degrees. Easy as that. See you guys on Thursday.